I suppose we should start at the very beginning. Where it began, I can't begin to know it. Write down this very large yet substantially unimportant number. 37241.869,438. Let's just go with that. Starting at the beginning, how many of you feel relatively confident that you could say that number mathematically? Mathematically speaking, how many of you think you could say that number? Zach Rice. Start at the beginning there, sir. What is this part?
37,241.
Perfect. Somehow I knew. I thought this was where we were on the wall. Ashley, you want to finish that? He's got the 37,241.
Point.
No,
Wait.
it's and. The
Oh.
decimal point is always the word and when you say it technically.
Oh.
Let's jot that down just to make sure. This is the word and. Yeah, which one I could? Uh-oh. Could we use of?
Yeah.
No, it's and. Ashley, go on.
869. No, not 800. Wait, no.
By golly, we will learn something today whether we like it and or not. Taylor Pavia. I'm going to give one more person a shot and then we're forging ahead into new and very much charted waters. Yes.
Then you should give somebody else a chance to help me.
Okay. I already had Zach, so let's go with Mr. Alex Martin.
37,241 and 869,438 millions.
I believe he has it there, ladies and gentlemen. Now, technically speaking, kids, this is what would make your life a little bit easier. Just like there is commas to the left of the decimal, okay, you should look at this in three parts. You've got this number, which everybody had. I'm pretty sure all of you could have said this. You got the decimal point, which is the and. Now you just got to work with the part that's to the right. Technically speaking, you should put a comma in here because that is how you read that number as well. Okay, this is going to be read just like it would if it was over here. It is 869,438. And then you have to finish it off with whatever place that last digit is in as far as decimals go. And you need to make sure you know the decimal place value thing. The first place after the decimal is that tenths place. Okay, and then you go to the, you should know these, the hundredths place, and then it's the thousandths place, and then the 10,000ths, and you have to make sure you put that TH sound on it, otherwise it's over here. Then you've got the 100,000ths, and then you have that place there which Alex said was the millionths place. Okay, it is the millionths place. Please note there is no ones place or no units place. And that's what kind of throws people off. It's the mirror image of the left side, except there is no ones place there. It's just the tenths, hundreds, thousands, 10,000s, 100,000s, millions place. Really, a good way to think about this is, okay, whatever place this would end up in, this is in the 100,000ths place. Okay, when you say that last digit, it's going to be one place more. In other words, it's not the 100,000ths place, it's the millionths place over here. So if you said 869,438, you'd say millions place because it's one place smaller, numerically speaking, or number-wise, than this place was bigger over here. Sam didn't catch that, but I'll show you. Let me give you another example. 36.8059632. And again, putting the commas in this makes it a little bit easier to read. Okay, because when you say this decimal part, you're going to say 8,059,672. Because this was 8 million in the millions place, the decimal at the end actually is going to be the 10 millionths place. If this was millionths to start off with, if you said the word million up here, or if this one is in the millionths place, then your decimal's in the 10 millionths because you're missing the units place. It's tenths, hundreds, thousands, 10,000s, 100,000s, millionths, 10 millionths. Isn't that amazing? Isn't the wonders of math, Sam, just making you very, very, very excited about this next number I'm going to put up here? How about this one? 75.000808. We find a new place to put this. Let's try it over here. Which, by the way, we haven't even come close to get the lesson for today. But I thought this was very intriguing. Now this one's going to be a little trickier because we don't actually say what place this number is in. But what is this place? If you're looking at it from on the other side, this is the. If I didn't have a decimal there and I had a number right there, what place would that be? Well, this is the 100 millionths place, right? So the decimal place is going to be the. Nobody catching that? Tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and billions place.
Oh.
This number is 8 and 3,686,905 billions. Again, I'm just trying to get you to see it's one decimal place. The decimal you say at the end is one place farther than the decimal that it would be in the front place. Now, on to what really is the lesson for today. Let me see. I should have thrown up some examples there. The book is going to ask you to do this. Write this down. Order from least to greatest. Order from least to greatest. And they will give you something like this. 0.5, 0.41, 0.05, and 0.405. I wish my thing would write nicely, but okay. Please understand, unlike decimals, unlike numbers that don't have decimals in them, it's not how many digits you have that makes it a bigger number. It's where the digits are in the number. So when you look at this, your first inclination is to go, oh, 405, 4, that's bigger, that's got more digits, it's bigger than any of the rest of these. That's not true. Okay, because you really have to compare one place after the other. In other words, this, what you can do, you're always allowed to add zeros after decimals and it doesn't change their numbers. But you can't do on the other side. If I have the number 5, I can't just randomly add zeros and it doesn't change the number because that changed from 5 to 500. But if I have the decimal 5, okay, 5 tenths is the same thing as 50 hundredths, is the same thing as 500 thousandths, is the same thing as 5,000 10,000, which is the same thing as 50,000 100,000, which is the same thing as 500,000, which is the same thing as 50, I don't know where am I at, which is the same thing as 5 million, 10 million. So, if you struggle with this at all, what you should do is, since this has 3 digits after the decimal, add the zeros into these to make them so they're 3 digits after the decimal. So now comparing the decimals looks like this. What's bigger? 0.500, 0.410, 0.050, or 0.405? Which one is the smallest of those up there, Taylor? Exactly. This is 50, so it's the smallest. 0 point, and you can just take the 0 off now. Okay, so I'm done with this one. Of the rest of those, what's bigger? What's smallest? 500, 410, or 405? Zach Rice? 0.405. And then of the two that are left, 0.500 or 0.410, Ashley, it is?
0.410.
Right, so just 0.41, and then this last one is 0.5. So you have to get out of your mind that how many digits it is makes it the difference on how big the number is. That's not true with decimals. Let's see what else they ask. Now, what about making fractions decimals? I told you it was going to be fractions to decimals. We did this last year and there's a couple different ways. Let's say I asked you to change those fractions into decimals. Again, you can be your own boss and do whatever way works for you. How about the first one? 8 over 10. How do you make that a decimal? Kyle Westfall. Say that for me. Okay, how do you make 8/10 a decimal?
0.8.
Okay, it is exactly what it says. That's what 8/10 is, 0.8. 8/10. You are right here. Where was it? I think you're with Morgan.
No, he's right here.
You're with. Oh yeah, you're with. That's what I was thinking. Okay. In other words, this: if the bottom of the fraction has a 10 or 100, you can just write it as a decimal because that's what decimals are. Decimals are tenths and hundreds and thousands and things like that. Same thing. This one though, 3/8. Okay, I have people do this and it makes me laugh every time. Actually, it makes me wonder. Oh look, 3/8 must be 0.38 because there's a 10 no. Okay, 3/8 is not 0.38, although it actually ends up being pretty close. But it's not. That has nothing to do with it. What do you do with a fraction when you cannot change the bottom into a 10 or 100? You're left with doing what, Caroline? Sure, why not? What does that mean? That's a good mathematical term. If you ever want to get into it with a math teacher, just use the word simplify. Well, you really can't simplify it. How can I change that to a decimal? Somebody besides Sam. Sam.
Multiply.
5.
8. Multiply 8 by 10.
That would give me 80.
And multiply 3 by 10.
Okay, so you're 30 over 80 is what is a decimal.
Oh, wait, doesn't work. Wait.
It's a thought. Now that would work over here, because I can change 5 and it goes into 10. Not so much with 3/8. Somebody, Ashley?
So you would divide 8 by 3.
A fraction, ladies and gentlemen, is nothing more than a division problem. That's what it is. You just take 8, the bottom goes into the top, which doesn't make sense because you're dividing it a bigger number by a smaller number by a bigger number, but that's what makes it a decimal, because you put your decimal in there and add the zeros. 8 goes into 33 times, that's 24. 8 goes into 67 times, that's 56. And you have to keep going until it works out. 8 goes into 45 times. 3/8 is the same thing as 0.375. That is its decimal equivalent. If you can't change it into tenths or hundreds, that's what you have to do. And sometimes you'll get repeating decimals that don't work out. For example, 7/9. If you get 7/9 as your fraction, you're left with dividing 9 into 7. You end up with, how many times does 9 go into 70? 7 times, that's 63. Guess what you keep? How many times does 9 go into 70? 7. You get 63. How many times does 9 go into 70? 7. The decimal for 7/9 is 0.7 with a repeater sign over it. Matter of fact, that's the case with anything that has a 9 under it. 2/9 as a decimal is 0.2 repeater. 2/9 as a decimal is a 0.2 repeater guarantee. Now, how about this one? 7 1/5 as a decimal. Nate Cook. We can just, let's go start by this. We know it's 7, whole number, point. 1/5, changing 1/5 to a decimal. Okay, this one, you can easily make into tenths by multiplying top and bottom by 2. So 2/10, 7 and 2/10. Okay. You can always do this, by the way, even with 1/5, but if you can think of an easier way to do it, you might just as well do that. Oh boy, the excitement now minutes. Remember I said everything you wanted to know? How about changing percents to decimals? For example, 5%, 82%, 335%. Zach Rice, give me some direction here. I want to change 5% to a decimal. What in the wide, wide world of proverbial sports would I do? Oh. I told you 7th grade math is a touch bit, just a touch tougher than 6th grade math was. Matter of fact, the 8th graders are doing 7th grade math right now. At the end of your book. Tough. Tough stuff. Ava.
You could change it into a fraction, like 500.
Perfect. 5%, by the way, the little percent sign means 100, is the same thing as 5 over 100. And how do you write 5/100ths as a decimal?
0.05.
0.05. Well done. So 5% is 0.05 as a decimal. 82%? 82%? Kendall, how would be what as a decimal?
82 is a fraction, so 0.82.
Very good. It's 82 over 100 as a fraction, so it is 0.82. Now, ladies and gentlemen, mathematics is all about finding a little pattern, and I'm not about not taking shortcuts. Okay? Rather than going and writing the percent into the fraction going to the decimal, you should notice something about this going to this and this going to that maybe you could come up with a generalization or a rule, if you will, that might get there. Taylor says,
You just put the decimal at the beginning of the number.
well, unfortunately, that almost works, but not quite, because if I put the decimal at the beginning of this number, it's not 0.05, it's 0.5, and 0.5 is not the same thing as 5% because 0.5 is 50%. Another shot at Taylor.
Well, if it's one number, then you just add a 0 to the front of it and then put the decimal.
So what's this one going to be? What's your little thought process there?
Or and, right? Because you said decimal is always and. So, and 335.
No, I'm sorry, that's not. You're close, but you're missing the one simple little thing there. Ashley says,
Okay, so if it's a single digit, there's a 0 right before it. Then if it's if it's 2 digits, then there's no 0. Then if it's 3 digits, then it's then the first number, like, it should be 3.35.
okay, can you give me a rule that I wouldn't have to say, well, if it's 5 digits, you have to go and there's 2 digits, 3 digits in front of it. I'm looking for a vast generalization that'll change any percent to a decimal. What could be our rule?
There's always a decimal.
There will always be a decimal, but that doesn't tell us where the decimal goes. And Makunacek?
Since there's 2 zeros in numbers, there are always 2 places after the decimal.
Yes, but can you give me, you actually have it there, but an easy way to tell it to somebody. Mika.
The after the decimal always has to be in hundreds.
Yes, but there's an easy, is there just a simple little rule? Gabby?
Decimal point goes 2 places.
The rule is this. To change percent to a decimal, you just need to move the decimal 2 places to the left. Okay? And you're gonna say, well, these don't have decimals in them. Well, every number has a decimal. If it's at the end, we just don't write it down. There's a decimal here, there's a decimal there, there's a decimal there. The rule is you just take it and move it backwards to the left 2 places. 1, 2, that's why I had to add 0. 1, 2, it came in front of the 8. Here, 1, 2, it comes between the 2 3s. 3.35. Good. Hence the reason when you have 100% of anything, 100% of 6 is, anybody? If you have 100% of anything, what is it? 100% of 6 is 6. Why? Because 100% as a decimal, the decimal starts here and you move it back one place, it's the same thing as 1. When you multiply 1 by anything, you get itself. Okay, so if I gave you 100% of what I have in my wallet, I give you 1 times it, which is what I have there.
0.
200% though, what happens if you give somebody 200% of something? You actually double it, because when you move the decimal back 2 places, you end up with a 2. Okay, if you gave 300% of something, you gave 3 times what it is, because you move it back 3 times. How?
Do we have to draw anything?
Not really. No sketching involved, actually.
Why is it that when you multiply something by a decimal, it's smaller than it was before?
It's not always smaller. If it was 3.6, it'd be bigger, because you're multiplying by a 3.
Oh.
Same thing as multiplying by a fraction. When you multiply by a fraction, you always get something smaller too, unless it's an improper fraction, then you get something bigger. Because you're multiplying by something that's less than 1. When you multiply by something less than 1, you're going to get less than what you started with.
Oh.
Now, as a last and final and most exciting thing here, here is what the greatest book ever written for math is going to ask you. And now I will ask you as well. You have 1/2. You have 12%. You have 1.2. And you have negative 1.2. Right now, I want for you to arrange that in order from least to greatest. What is the smallest of those, and what is the largest of those? Which one is the smallest, which one is the largest, and which go in between in order from smallest to largest? Oh, it's killing me. Philip, would you like to assume that you're gazing off into space meant you were done with it, or you just lost focus? Oh, okay. Yeah, I got you. That's good. And how do you know which is smaller, bigger? Done, how? Are you 100% sure of your answer? 100%, are you 200% sure of your answer? What percentage of your answer are you sure? 800%?
Yeah.
That's why when coaches tell you to give more than 100%, realistically speaking, you can't do that. For somebody to give 110%, really, 100% is all you got. You can't really give 110% even though they say that. They just want you to try a little harder. Alright, here would be, who has not yet answered the question? Morgan! Give me in smallest to biggest terms here.
Negative 1 and 2 10,
Yes.
and then 12%, then 1/2, and then 1 and 2.
Raise your hand if you agree. Oh, we've got some disagreement out there. Don't always jump on the bandwagon. Here's the deal though, what you should have done first, and I'm sure Morgan did this, you gotta get them all in like the same sort of ballpark here. It's very tough to look at a percent and compare it to a decimal without knowing what they are. So the first thing I do is make them all decimals. 1/2 you should know is 0.5. 12% we just talked about moving the decimal back 2 places, it's 0.12. This already is a decimal, this is already a decimal. Well, the negative one, obviously negative numbers are smaller than any whole number, positive number, so this is true. So now we've got what is bigger, and again, feel free to add the zeros there to take a look. Okay, what's the next smallest one? The 12% was right, because that's 0.12. and then the 0.5 has to be the half. This is bigger than 1, so it has to go over there, so. Those of you that did not, anybody questioning why that is or what happened there?